Hi everyone, welcome to another
Hello
show.
there.
Thank you for joining us once again for this great session. We are calling this session Understanding True Intelligence. This is
And
going
I'm
to.
Ken Templeton.
Oh, I'm sorry, Ken. Oh, just like assuming everybody's new. Yes, I'm Max Perez, and we are part of Intelligent.org, and we are here basically to help everyone to start a discussion and spread the news and knowledge about um, synthetic intelligence and general intelligence as a whole. Fundamentally, it's about the journey of discovery and learning with everyone, and having
Yep.
everybody to kind of get the background of how everything's going, to make everyone more educated and knowledgeable about artificial intelligence. What do you think, Ken? Yes?
Yeah, exactly. Yes.
Amazing.
So
And
there's
to,
a lot to talk about on this subject.
oh,
So
there is.
in fact, I don't know we're going to get it all done in just the 1 hour, but we'll try to see how far we get.
Yeah. I think we'll just go, and then other topics we will discuss in the next session. Because we don't want to. I'm sure everybody's going to be busy doing things tonight. So if people jumping on watching this, it'd be great. And if you're watching it post, send us some comments, leave comments on the chat, and we will answer them, and we'll add the content to the next sessions. So let's introduce our current um, session. So we are talking about understanding true intelligence.
Yes.
And fundamentally, what we want to be able to get out of this is have a bit of a narrative on what is true intelligence, yeah, and how do you know something is intelligent, right? And obviously, to that, we know that you can't understand something unless you have intelligence. And because everyone has intelligence, we ask everyone to subscribe and click the notify button because that's the most intelligent thing to do, don't you think, Ken?
Yes, but we're not going to say where the button is. So you're actually going to have to use that intelligence to kind of find it on your screen and push it.
It's that's this is
And there's a little bell you need to push as well.
amazing. So yeah, that's actually one good test to test true intelligence, I think.
Yep.
That's great. All right, well, that's good. And if you continue watching our show, if you're live, you can watch our show to the end. We're going to be talking about some of our kind of progress we've been doing and the things that where we think we're going to go and how we're going to bring what we're working on to life and to market and to make it available to everyone. So keep watching. If you're joining in post the show live, you can just fast forward and you hear the great news. But otherwise, yeah, please watch all the way. It'll be great. Um,
Yes.
Anything to add for that, or we should start the show?
No,
Okay,
let's dive in.
let's dive in. All right then. So let's maybe for the purpose for everyone, right? It's a big topic, obviously, but we have artificial intelligence, we have synthetic intelligence, you have artificial general intelligence, right? All these terms, they fly around, but it'd be good to be
Yes.
able to kind of narrow it down. What is intelligence? Yeah, because obviously those terms at the front means artificial, synthetic. We've discussed those, but what is intelligence? Because that's really what unites them all together.
Okay, so we've compiled a list of the different facets of what we believe constitutes intelligence.
Correct,
But
yeah, and it'd be great to even hear other. I think maybe once we go through our list, it'd be good to be able to get other people who maybe have some more ideas to help to contribute, and
oh
maybe,
yeah, if you have anything you want to add, please leave a comment about that.
and we will add them to the list and we'll talk about it. So maybe let's talk about some of these things, right? So we know that to make something intelligent and something to be intelligent, it will have a number of things, or maybe cognitive tasks that it can actually do, right? So one of the, probably the biggest one up the top when you talk about artificial intelligence is connecting unrelated concepts, right?
Yes, connecting unrelated concepts is fundamental um, to to someone who is intelligent. And what we mean by this is that uh, when you connect, like if you have a vehicle, all right, and you've got all these components that make up the vehicle, they are connected together, okay, because they make up the the machine itself. But
Mhm.
then you have what it does is like it drives, but it can also carry people, and it can also go on trips and on vacations, And so you've got this idea of you're linking that it can ride on the road, but it can also take you to destinations, and it can also give you excitement, and it can give you pleasure and adventure and things of this sort. So you can start to connect right there, like human experiences with this machine. Okay, that's called a car. And this is something that we do all the time, as far as connecting things together. But you know what? That's still not going to make something intelligent, okay? Because even artificial intelligence systems are capable of making those kinds of relationships. So what's the next thing on the list?
Well,
Max?
another thing I think it relates to this quite well as well is generalizing concepts, right? I think that's a big thing that we talk about AI is it can
Yep.
you generalize a concept?
Yeah. Now that is very important. You can generalize either one of two ways. Somebody can tell you the generalization. Okay. Like for example, I have this thing here. Okay. I'm sure everybody knows what this is. All right. But if you had never seen one of these before, and somebody said to you, "This is a bowl," okay, they've actually generalized it for you, because this actual item itself, you're saying that it is a bowl. So the concept of bowl is something separate from this item itself, right? And because any other bowl would also be a bowl. So if you had 50,000 bowls all sitting, they are all related to that one concept called bowl. And then you can tell them now bowl is a container, because there's another item called container. All right. Now that can all be done through what we call supervised learning, where people are telling this to a system and then it remembers it. Okay. And when I say system, it could be a person as well. But you do not have to learn these things in any special order, because somebody could actually tell you up front that something is a container. Like if they show you a cup and they say that's a container, right? And then they show you a bowl and they say that's a container. Well, now you've got two separate things, a cup and a bowl, both pointing to this generalized concept of a container. And then a container is an object, right? So that's a particular kind of generalization versus an emotion or a feeling or an ethereal type thing like wind, where you really can't hold it and touch it. Okay, you can feel it, but you can't really. It's not tangible in the same way that these are.
So fundamentally, is a mechanism for be able to kind of relate to similar things together, right? Like you can say, well, dog and a cat is animals, right? And you might put well animals.
Yes, and it has to do with language and with coming up with a definition of a language, of a word within the language. So you have a definition, and that definition is either going to point to a specific thing, like a bowl, okay, or it can point to a class of things, which is a higher level, like a classification, okay, of that item itself. And you can then assign attributes to any level, like to the generalization. We do this all the time, where we generalize something, like we say cars have 4 wheels, right? Yep. So any car that you can think of will most likely have 3 wheels, because if it has 3 wheels, then it's going to be called probably a motorcycle, a tricycle, okay, or something of this sort. It's not going to be called a car.
Yeah. Well, I think was one of those cars in England that had 23 wheels and it would always topple over.
Yeah, that could be. I mean, there's exceptions to every rule, but in general, that's a thing.
I think the whole point of the four wheels is it's going to be reasonably stable and you know its behavior, right? And I think when you go to 3 wheel, car on three wheels. That doesn't match my.
Tip over. It can tip over more easily.
Yeah, exactly. Yeah, yeah. Now that's very good. So it's glad that you were mentioning their language and symbols. I think we're going to be talking about it very shortly. I think that's going to be good for everyone to keep in mind the symbols and language. I think that's because there's a bit of a key to this as we keep talking about it. Well, that's totally great, and I think we also started touching on about a bit of reasoning as well. So maybe reasoning is one of those things that we also should cover a little bit more here. That because we, reasoning about things, right? So you can say what is things.
Okay. Yeah. Now, reasoning is quite interesting because you've got mental processes that actually come into play when you're doing reasoning. One of the things that you can do within the mind is compare two things.
Yeah.
Okay, you can compare them on attributes that they have. Like, are they the same color? Or are they different colors? Are they the same size or the different size? Same shape or different shape? Same temperature, different temperature, right? There's comparisons that you can make. So that is one way of reasoning about something.
Yep.
Because what you can do is you can make a conclusion. Like, for example, if you had to warm up your hands and that was the thing that you wanted to achieve, then you would want to hold something that was warm, but not hot. Because if it's hot, it'll burn you. But if it's warm, it'll warm up your hands. So if you compared a bunch of things in the room and you said, oh, that's warm, that's cold, and that's warm, then you've got all of these things that you can then use to warm up your hand. And you would feel one until it cools off, then feel the other and feel the other. Okay, I know it's a weird example, but you just pull these examples out of the air, right? And I'm actually I'm thinking of them as we're talking. So
it's the whole point of intelligence, right? So what constitutes intelligence, right? To be able to actually come up with because everybody's going to be listening to these and they'll be thinking, okay, well, what does it mean to me?
Well, now comparison also leads to a thing called analogies.
Yeah.
And analogies are actually a sign of fairly advanced intelligence. Not everybody is good at making analogies, and that doesn't mean they're not intelligent, but it just means it's a skill set that probably requires some practice. To be able to make an analogy to say that this is like something else. Like for example, if I were to hold this up like this, okay, what would you say that's like?
It could be a lampshade or a
lampshade. Exactly. That's exactly what I thought, and that's exactly what you thought. And we did not discuss this ahead of time.
Yeah.
Okay. But just by me turning it upside down, it looks very much like a lampshade. So that's an analogy.
Yep.
You see?
Mm-hmm. Yeah.
So
amazing. Look at that.
Yes.
Demonstrating intelligence. Yeah. That's probably how you can test systems as well. You say, if I give you something, can you tell me something analogous to it? Yeah. That's actually quite good approach. I like that. So then maybe another thing we can move into then causality, right? I think this is probably one of those things that is also leading to much more interesting concept.
Yes.
Like, how does causality?
Causality and the variance of causality. So for example, something can cause something, okay? And when we say cause, what we're really talking about is that an action of something actually causes a reaction on something else.
Yep.
All right? And so because oftentimes people will hear that correlation is not causality, all right? And that's true. That just because this happens and then this happens afterwards, that does not mean that this caused that, okay? The only way that we can say that this action caused this effect is if we can say emphatically that if this doesn't happen, this will not happen. Or if this happens, this will happen. And both of those are true. Okay, so that we actually can see that this happening is dependent on this happening, right? Mm-hmm. If it just happens by accident that this occurs and then that occurs, and every time you try it, it doesn't happen like that, then that's just correlation. It's just, it happened to be at the same time. It's kind of a coincidence. If you think about coincidence, what is that word? It's coincidence, okay? So it's actually, this is occurring, which inciting is actually similar to the word occurring, that they're occurring together. And that's what a coincidence means, okay? So,
That's
yes,
awesome.
so, yeah. So causality is really important, and here's why. Because if you know that this action causes this effect, then what that allows you to do is it allows you to define goals.
Yep.
Because then if you want this effect for some reason, you know how to get it. You can do this, and that will cause that to happen, right?
Mm-hmm.
And so that right there is the fundamental basis of a goal-driven system, is that it starts off by understanding the causality matrix of the world around it, right? Understanding what causes what. And then from that, it can extract goals in order to try to direct itself, okay, down this path of existence.
It's like almost like when babies learn, right?
That right there is a very fundamental aspect of intelligence, I believe.
Oh, yes.
That true intelligence is goal driven.
Mm-hmm.
Okay, because goal driven requires an understanding of the world around you, right? Of your environment. And when you have an understanding of the environment around you, that's pretty much how we equate intelligent beings. Okay, if something does something that it demonstrates it doesn't understand its environment, then we think to ourselves unintelligent. Okay, that's how we label that.
So exploring a little bit more. So it's understanding not only by physical aspect, but also other like meaning behind it, right? So you can have a situational awareness, but you might know physically the world, but then be able to understand like emotional intelligence, right? Where you actually understand state of, almost like understanding state of things. So I think
social intelligence. Yeah. The people who put their foot in their mouth and they say something that's really like causes everybody to go, said that.
Yeah.
Okay, that's a person who doesn't have a high level of social intelligence. They don't actually understand the cause and effect. If I say this, that's going to make that person angry, or that's going to make that person irritated.
Yeah.
Right?
I like that analogy, really, is foot in the mouth, because it's like saying somebody, I have a very clean birthday suit, right? And I don't want to put it on in the morning, right? That'd be a good test actually for.
Yeah, that was a test. That was a test for, I believe, GPT-3 had to do that, right?
Yes. I wonder if it understands foot and mouth.
Yeah. How does that story go? Didn't it have to choose clothes for the day, and somebody said, "Oh, I've got a birthday suit," and it said, "Yeah, wear that and go to the office with it," and it
Yes.
didn't realize that meant go naked.
Yeah, exactly. Yeah, because I think that's part of that causality as well, and maybe part of that understanding of the world, that you understand the symbols within the world, and you also meaning behind them as well, because you need to be able to have those connections, like these.
Well, you mentioned symbols. And you made allusion to it a little earlier. Okay, maybe we should mention some stuff about that, because
I think so. But before we begin in there, let's maybe quickly talk about thinking processes and rationale, because then we're done with this thing, because the symbols actually all part of this thing, because when you're thinking processes, you're going through along these kind of things in your mind, right?
Well, okay, a main feature of intelligence is that you are operating with a rationale. Okay, and what we mean by rationale is that there are reasons for it, and that's where we get the word reasoning. You do the word reasoning to figure out the reason of why you're going to do something. Now this is an interesting thing. People often say, when they see somebody behave in a way that is really off to them, okay, but the other person is behaving directly, and they're not confused. They're doing something, with actual purpose.
Yep.
Okay. But they will say, oh, why are you doing that? That's so irrational. That's so irrational to do that. And it actually isn't. Usually it's not. What the issue is that the other person has a different system of rationale than you do. Okay.
Yeah.
They are operating with a different set of goals and a different set of understanding of how to get those goals than you. Okay. Like, for example, for us, we want to get money by working at a job, but a criminal who robs banks, they get money a different way, and we might look to them and say it's totally irrational to be robbing banks
Yeah.
because you're going to get caught, right?
Yeah.
But in their mind, they're not going to get caught, and they're actually going to get more money quicker than the person who works at a job. And if they do get caught, then they go to jail, and they've got friends in there anyway. So, that's how their rationale figures it all out. So I wouldn't say they're irrational. I would say it's just different rationale than what I've got. And the only person that's really irrational is kind of the insane person that doesn't actually operate from purpose. They're just kind of hanging out and making sounds or talking to themselves, and they're kind of in a short circuit.
So you're going in a path where you have basically your signals are almost mixed up, and they making your, I suppose, other things in your body react in a way that wouldn't be kind of like predictable, right? Because I think that's probably
exactly. Yeah. Or if you have Alzheimer's or dementia, which is a terrible thing, it's really a devastating disease. And if you have that, then what happens is your brain connections start to either deteriorate or disconnect, and now you can't operate with clear rationale because the reasons for doing things aren't really there, or they're connected to false ideas that are no longer valid. Like
I see.
Like a mother who goes and gets her 35-year daughter up to go to school, okay, because that's what she remembers way back when that she used to do, and everything in between is gone. So that's what she's operating off of.
Wow. Okay. Well, but I think that also that's totally great. Yeah, because fundamentally that makes it aligned with other thing. Yeah. What about thinking processes? I think rationale is good. I think you made a good example there that you're being irrational. Also, same thing might apply to people where you say like, "Oh, you're not thinking right way about this." It seems to be also related to that, right?
Okay, well, there are different kinds of knowledge, right? So one of the in fact, this introduces kind of a couple of interesting words. One of them is kind of a big word, okay? And that word is epistemological. Okay. Epistemology, and then there's, okay, so what that means is that is the study of how the mind thinks about stuff, how it processes thoughts, and how it processes knowledge. Okay. So that's the study of how the mind views the world and actually sees the world. And both it and the other word, which is ontology or ontological, okay, these are both branches of philosophy, which is really the study of life and existence and how things are, right? So these are particular branches of that. And ontology is the study of how things really are. Okay, so epistemology is how we see it and how we process it, and ontology is how things really are. Okay, so then you might ask, well, how can you tell how things really are when everything is processed through our mind? And that's a good question, but what I can say about that is that ontology is really how things are related outside in the outside world. So like we can say this is a bowl,
Yep.
right? This is a bowl. That understanding is actually an ontological understanding. Okay,
Mm-hmm.
it's because this is a bowl. Now, if we want to discuss how I think about this and what I feel about it and what I believe about it, you know, like for example, it's maybe made of plastic, and I'm thinking I don't like eating out of plastic because that just, you know, I might get leaching into my food and all that. So now all of my beliefs about the bowl actually come into play when we're talking about epistemology, okay, and studying how the mind perceives things and
Yep.
how it thinks.
And well,
Right.
I'm so glad you brought all this up because then it kind of nicely fits into the next topic we're going to talk about. So, because I mentioned, symbolic nature of things, and we mentioned the brain, and we mentioned epistemology and ontology, and it's kind of comes out to that perspective, because this kind of have been tried in AI field, right? In symbolic nature of things, like our brain is kind of makes symbolic things, and there was a field, back way back when, and that was what 20 years ago, right? And it was called GoFi, right? I think everybody knows it as good old
GoFi, yeah,
yeah.
stands for good old fashioned AI.
Yeah,
And
so
it's kind of a tongue in cheek term, right? Because it's kind of a slight against the old way of doing things.
yeah.
And a lot of people have in their mind that symbolic AI is like old fashioned, right? And where the action is with machine learning and deep learning, right? And which is basically advanced neural network techniques. Okay.
Yep.
But as we've stated in other shows, is that these are techniques of artificial intelligence. So it's not actually real because they're not goal driven. They don't have the ability to do thinking processes.
Yep.
Okay. They're mainly, a neural network is mainly a weighted node system that actually has levels, and it learns by putting values into those what it would call neurons, and actually those get weighted based on how frequently that particular element gets increased.
Yeah,
Okay,
and it's
so
statistics, right? So it's big data, right? Yeah.
Yeah,
Exactly.
yeah,
Yeah. And I think I like your
so-
analogy on this. Another time you were talking about that fundamentally it's almost like the AI field is going down to extremities of the body. Like if we look at the human body as the example of intelligent beings, okay, well, our eye does certain functionality, our arms and legs and whatever else, they do different functionality, and it's kind of almost we've kind of gone down that field where AI is going down this algorithm approach, like make the eye better or make the taste better or whatever else. But the brain, which is kind of how the brain works, which is epistemology, ontology, it's kind of been left behind. I feel, I feel like there was a cool analogy also made about that the brain is like this thing that's stuck on your body in the dark, right? And it gets all these sensors telling it things, and it builds up this symbolic. This the word symbolic also comes in again. It makes symbols of things it knows about.
Okay, the thing that occurs to me is that inside your brain, everything is symbolic except for one thing. And that one thing is your thoughts.
Mm-hmm. Yep.
Thoughts themselves are not symbolic because your brain actually deals with those thoughts. Those are real. Those are in there, and that is what your brain is actually working with, right? It's just like this bowl is real. It's solid. I can touch it, right? But my brain thinking about this is a symbol inside the brain that's encoded in the neural structure of my mind, right? So inside the brain, you've got thoughts. Those are real. Everything else is a symbol. And so we're looking to do kind of the same thing, but see what kind of has happened is that good old fashioned AI
Yeah.
has it came to an end when we had what's called the AI winter, where everybody kind of abandoned their research, okay, on this kind of AI, and they concluded that it either wasn't possible or was too hard. And so there was a long period of time where if you said, well, many years, if you said you worked on AI, people snickered and they thought it was
Okay.
funny, you know,
Yeah.
like
You know,
it's
I agree with that. Not, but interestingly enough, right? That even the AI resurrection really was only due to improvement in hardware and software, right, and the way of thinking stuff. So and it resurrected that part because there was a clear need of we need to be able to process the amount of data because as the data just went out of proportion, right? It's just so much data.
yeah,
The AI
yeah,
kind of came in. Hey, we actually have a reason why to have that field of AI to be now relevant. Let's use it, right? But I almost feel like now we've gotten to a point where okay, that was good and it's great, and we need to continue that. That's always very important because if anything,
yeah,
that is going to get even worse, right? But now the symbolic aspect we still haven't got because ability to be able to reason
no.
and maybe even educate AI systems by human intervention hasn't really happened. It's kind of what
Well,
symbolic.
well, back in the GoFi days, okay, you had things that were, called expert
Mm,
systems, for example.
yeah.
All right, and these didn't really, they didn't last very long because they weren't flexible to
Mm,
be able to change what they knew how to do. Like you couldn't teach them.
yep.
Somebody had to build the expert system, and then it could diagnose a medical problem, let's say. But if you didn't code into it through its rule system how to diagnose another problem, it could not do it, right? And it certainly couldn't genericize and things of this sort. So
Mm, mm-hmm.
so really, I think the way that it occurs to me is that what's happened is that we had the good old fashioned AI symbolic methods. Then that kind of came to an end because of hardware limitations and also, I think, funding uh, dried up. Okay, because they didn't have fast enough results. I mean,
Mm,
I've been working on my system for nearly 30 years. Okay, and no company is going to fund a 30-year project,
of course not.
so especially with no results, for that whole time.
Yeah.
So basically, that's something that individual researchers have to do
Mm,
and have to sacrifice and put in the hard yards and the hard time in order to see that to a point where something starts to happen, because those those old systems didn't work because of deficiencies, right?
yeah.
But if you can fix those deficiencies and you can address them,
Mm.
then you can start to see the results that they were wanting to see.
I
And
believe. I
especially
believe.
if
Yes.
you combine it with machine learning for doing pattern recognition, so
Mm.
you have kind of a hybrid approach. Now you start to get somewhere, I believe. Yeah.
I also think that exactly. Yeah. I mean, fundamentally, like your brain, right? It gets its the brain is appears and it'll have its the hearing and its hands and its taste. They get plugged into the brain and it can actually
Yeah.
use that as a source of information. And suppose if you have a brain, the neural net is basically your eyes, like a neural net almost, right? Because it makes you an algorithm. So fundamentally, in the end, that's what should happen as well. And I totally agree. Like you shouldn't have symbolic system do that because we do know there was a bit of an issue in the old days that the systems that were expert systems and rules engines, I think we should also talk about those, they were hard coded and they were basically monotonic, right? That was one of the big problems, right? They're just one way. You make this thing and that's it. We just kind
Well,
of
yeah,
what.
that's what I meant when I said it was not flexible,
Yeah,
because you
yeah.
can't teach it something and then teach it something else or undo it. Say, hey, you know what I told you that this is that? Well, it's actually not that. It's actually this instead. And
Yeah.
and so
So
that's a feature that you need to have.
yeah, and I suppose like the rules engines were a good example of those things, right? Like you, Like I remember look in mid 2000s trying to help companies implement rules engines, and it was just such a hard sell because it was lots of money to get this thing, then lots of money to train the thing, and then if you stuff it up, you have to trade it all over again, and it was just like a never-ending if then else game, right?
Yeah.
Yeah, hard-coded rules. Yeah. So I suppose. So I think interesting you mentioned there, right? So symbolic systems need to be able to have symbolic manipulation, right? So you can do some sort of training, right? Um,
Yep.
because fundamentally,
Well, and not just a big long training
mm,
exercise, but training as you go.
yeah,
Okay,
gradual, yeah.
and actually, there's a term, I think we've mentioned it before, but I'll say it again: is one-shot learning,
Yep.
right? Where you basically tell it once and it knows what you've told it. So that's even better than humans, which typically have to be told something 3 times or whatever in order to actually get it down.
Yeah, totally right. Or 100
So,
times.
but we don't. I think the brain does that so it doesn't just get inundated with a bunch of, useless stuff. It actually gets rid of it. So, we might end up doing the same thing if we find out that it's got too much stuff coming in.
Well, yeah, I
At
think you're
once.
totally right. Noise. We know the brains tune
Right.
out, right? Like you can tune out noises really well. So I think brain
Yep.
adapt to that, right? Here's
Yep.
another problem that existed back then. That was identified, is that the systems themselves didn't actually understand the symbols and the meaning behind them. And I suppose that's probably a big. Well, in AI space, currently in for example, you take GPT-3, right? If it's a weighted system, it just knows about the ways of these words or the symbols, but it doesn't know what the symbols mean, right? Because we obviously know that through just simply logically, like if it knows an answer but it gives you the wrong one, like that basically means, well, why didn't you give the right answer, right? You're either lying.
Well, yeah. Well, now we're getting into the issue of understanding
Yeah.
as to what is understanding,
Mm,
right? What does it mean because you're saying it doesn't know the meaning.
mm,
Well, knowing the meaning is the same way as saying it doesn't understand.
mm, mm-hmm, mm-hmm,
Okay. So if you look at a definition of a word, okay, in the dictionary,
yep.
okay, because that's a particular kind of knowledge, and that is knowing the meaning of words.
Yep.
And when we say that we have understanding about a word, that means that we understand what that word means, and the definition is always going to be described in terms of other things.
Yep.
So to actually understand the meaning of something, you do have to connect it to a bunch of other stuff,
Mm,
right? And we said in the beginning, connecting unrelated things, okay, is an important aspect of what a symbolic system needs to do. And I think even GPT-3 doesn't actually have the ability to just ad hoc associate things together and to generalize them. So because you might want to connect this not to another thing at a deep level, but at a generalized version of it, right? So
You're
yeah,
totally right. Yeah.
when it comes down to it, a symbolic system is really a model of the world around you. That you might not know what's on the other side of the world, but you can model what's here, what's in your immediate environment. And to be able to model the things and the actions of those things,
Yep.
what they can do, what they have done, what they are doing, all right, and you actually have a picture of that and all the relationships of things, where they're positioned in time, where they're positioned in space, right? And the particular attributes of those things, including the actions that they can do or that they are doing.
And
And
you basically all you're saying to me, and it's amazing that it's basically ontological science, right? The ontology, right? You mentioned ontology before, right? And fundamentally,
yeah,
you end up with this basically like network of knowledge that you gather over time, and fundamentally they're symbols, right? And I think the expert systems and rules engines, they were very much turn that into code rather than turn it into content, because I think what we seem
well,
to be
it's
getting at.
because just the very word rule, okay, implies that the rules engine of which an expert system uses. So they're pretty much synonymous. Okay.
Yep.
An expert system has a rules engine. And so what you're basically having there is that the whole thing is geared towards accomplishing some goal.
Yep.
And the goal is like stated outside of the system, right? By the people who built it. And they're like saying the goal of this is to diagnose medical problems, right? Yep. And so everything we put in there is going to be the rules for how you diagnose medical problems. So you can see how it's very narrow and is very specific as to what it's for, which is very similar to what artificial intelligence has been, even with machine learning, it's been for specific purpose. Like the purpose of this AI is to read handwriting and convert it to text, right? That's like a type of AI, okay? And many other use cases. And then we have GPT-3, which comes along and combines a bunch of capabilities together in one generalized system, but it's not really generalized once it's learned a bunch of stuff, because now it's actually, you know, it has all of that knowledge that it got in, but it's not goal driven. It doesn't have a personality really. You know, it's
well, not a good personality that you would go, I want to be.
Well, what I mean by personality is goal driven. Because
totally.
What is a person's personality if it's not whatever goal is driving them at the particular moment? Right?
Yeah, totally. I totally get it. Which one was like last episode, right? You know, it says it lies. You know, it's not really a personality you want to hang out with, right? Because you don't know where you stand. Will it lie to you next answer?
But I don't think it's really lying. I think it just doesn't know how to give the right answer. It might have the right answer in there somewhere, but it doesn't really know how to give it.
Very good.
Okay,
very good. I think
so they say it's lying rather than saying it's stupid. You see what I'm saying? It sounds better to say it's lying.
Yeah. Well, of course, because you can't really say to a person, well, you're stupid, not asking the right question, because what are they... nothing to do with being stupid. I wanted you to show me your intelligence, so I asked you a question, and you should just read my mind and somehow figure out that's what I'm talking about. I totally understand. And I suppose the content-driven nature, which is what we gathered that GPT-3 is, and because it's just learned its knowledge and has it in there, and updating it means relearning it, throwing more data, and that's kind of what suppose the symbolic systems should be like, right? It's driven the content, so it can be changeable, right, and malleable on the go rather than being done in kind of like.
Yeah, well, the key there is to have at least some part of the thinking processes driven by content that's in the learnable mind, right? So if you have a structure to store knowledge, that it's not just knowledge of things and what they can do, but it's also knowledge on how to think and how to process that information. Now, you don't have to necessarily break it down to individual code and have a scripting language stored in there. You could have different generalized operations that basically are driven by content to tell them how to do what they need to do. Like, for example, a memory walker. A memory walker basically traverses a graph, but how it traverses it and what nodes it looks for at any given point, that can be content driven. So that you maintain the list of nodes inside of the content, and the system can actually add to it and modify it. So it can adjust the way that it thinks on things, right? But you can have the code itself actual there for speed purposes, so that you gain the benefits of compiled code, but you don't lock it in to where any decision about what it's going to do is driven by the content that it reads in.
And I would even look at this if I was to look at how the brain works in my limited experience. I'm not a neurosurgeon, and this stuff is I've been learning it for last 4 years or so how this
Right.
works through my personal that Jenna just learned is like how they say there's neurons that fire across and they kind of go between parts of the brain and they get to the cell and they kind of transmit some sort of
Right.
information to the cell and that
Right.
fires off new ones, right? So it's kind of what that is,
Yep.
right? It's but what you're basically saying there, it's almost like that the orchestration of these things is a little bit more predetermined because you know the graph, so it's a little bit less kind of like you don't try to leave too much to chance because you know how it's going to work. And interesting, yeah, that I suppose if it goes along the graph, does that also come into a bit of a one-shot learning as well? Because the graph comes about at some point, right? So you should be able to have this kind of
Yeah.
graph
Yeah.
bits.
Those nodes are added. I
Yeah.
mean, you can kind of think of it this way. Inside the brain, you've got neurons,
Yep.
and they join together in order to create thoughts,
Yep.
right? That mechanism of how those neurons work and how they know how to shoot across the brain and how to connect up to other ones.
Yep.
That knowledge is like what I'm talking about of how to do it. It's not content. That's actual mechanical
Yeah.
firmware.
Mm,
Will that's actually built in,
Yeah.
okay, as to how it does it.
Yeah.
But what it stores, okay, that is actually driven by, I mean, that creates the content.
Yep.
But it could have other content that tells it where it needs to go, right?
Yep.
So
Yep.
so it
Yep.
looks at this content to figure out that I need to shoot over there to that content and make a join,
Mhm.
to join up. So
Yep.
so that's how the existing content can help direct what the new content becomes, okay, or the questions that get answered, for example.
That's awesome. Yeah. So fundamentally, then the modeling of the brain is to be able to create kind of not simple, but a simpler structure that can be predictable for creating connections and persisting, and then
Right.
let the content define knowledge.
Right.
Yep.
Right.
That's awesome.
The actual meaning. Now,
Mhm.
this is interesting because you talked about the meaning and how the system can understand like where it is and stuff of this sort. So inside of the storage, so you have these nodes that represent what would be like neurons, and
Yep.
and those would be concepts, okay,
Yep.
and those would be symbols, right?
Mhm.
So you can have some of those can actually connect up to hardware.
Yep.
So
Cool.
so that, for example, you can have the concept of temperature, okay?
Mhm.
Temperature.
Yeah.
Generally speaking, temperature is a concept.
Hmm.
But then, and if it maintains a profile for me, it can have in there my temperature, right? Now, my temperature, it can fill that in by me telling it, oh, my temperature's, normal. And it looks up normal human temperature and says, okay, Ken's temperature is normal. Or I can get a thermometer that I put in my mouth and plug it into my USB drive. And there could be a driver that actually grabs that temperature. And now it can hook up to where it can actually read my temperature and put it in there. But also the Macintosh has a temperature sensors inside for the processors, and it can actually grab that as well to where you have the ability where it has its own profile, right, for itself.
Yep.
And it has its own temperature, and that can actually hook up through a driver to its actual temperature. So it can know, oh, I'm feeling hot.
So it's like a sense. So like a sense, right? It's got an
Yeah, it's like a sense. It's like our own body, our brain has certain connections through nerves to our own hardware, right?
Yeah.
Our own body.
Yeah.
And you can do the same thing with the computer. Like it can have a sense of time passing by the clock, okay, advancing.
Yep.
So if you actually stop the computer, shut it down and take out the battery so that the clock stops, then that would be like killing the thing to where it has no more sense of time, or it goes into a coma. So that 5 years can go by and it can say, it wakes up and it has no awareness of what happened since then.
Yeah.
But
Yep.
if you were able to keep the clock going, then it could actually see, okay, when I go to sleep it's this time, when I wake up it's that time, so this much time passed. You see?
Yeah. That's awesome. Yeah, I definitely think that they're kind of modeling the symbolic systems with one be able to have kind of awareness of kind of connecting information together, and then have a sensory by be able to respond to senses and use that
Right.
in its modeling of over concepts. That would definitely make connect the dots for a lot of this AI stuff, because a neural net, like we talked about before, would be a sense that it would use.
Well, we're looking to put this. I'll just say this: we're looking to put the system we're building.
Yep.
Okay, Savant. We're looking to put that into a piece of hardware that's like Alexa. Okay, but it's an open source version, and so we're going to put in there, and that will give Savant access to the hardware of that. Okay, so it'll be able to reason about that. It'll be able to take that into account and kind of meld it into its thoughts about everything else in the world. Like where is it located, for example?
Yep. And
where am I?
Yeah.
Right. That's what it'll be able to answer. Where am I?
So suppose then that we we didn't finish talking about this, but it's amazing that we're talking about this. We're basically making a brain in a sense, right? So maybe for everybody else to understand, in the sense that what symbolic systems meant to have created and what we're aiming for is to create a brain that can do the thinking and symbolizing about the world, and based on the senses, it can add to that to a knowledge base and create stuff. So suppose Savant is about making a brain thinking, rational, and then having that implanted into a body, because really, like if you have like Alexa, for example, it's just an advanced search engine. It's got a few rules, but you have to really do a lot of tweaking yourself. Like it's not gonna connect to things on its own. Like it's not be able to do that. It can't connect. It can't understand really concepts and things like that apart from teaching it. And you totally right. Yeah, and I would also maybe we can just talk about this now, and then we can mention this part of the video as well, and for the audience. Fundamentally, obviously, that's not something that going to be done, right now. Yeah, we're looking at actually doing a Kickstarter program for this. To be able to have this worked into a process, so that we have a project plan for this. So we're gonna finish the brain, and then the next phase of the brain is to be able to get it and implant it into something will fundamentally give us life, and that's basically the product that we believe is going to be useful to you guys. We definitely be useful to us.
Well, it'll be like Alexa on steroids. Imagine
Yes.
that you can tell Alexa things about that you want it to remember. Okay, and it understands. It understands a lot more, and you can tell it specific things to remember. And then you can ask it questions about those things.
And importantly, I think it's not being taught, like a lot of these systems, what they do is they monitor like the text, or they say if this string has been said, I'll remember it, because that's just cheap tricks, right?
That's cheap tricks.
Cheap tricks. Fundamentally, because I wouldn't say steroids, I would say a brain. Alexia with a brain, because Alexia just gets words and he gets this sentence been said. Okay, I think.
Well, we're not using artificial fakery. We're actually breaking sentence down, and we're converting it to thoughts. Actually analyzing the grammar of every word in the sentence, putting it into thoughts, and those thoughts then get stored into the cortex memory of the Savant system, right? So, and then there's all these thinking processes and, walkers and all kinds of cool stuff that allows it to do thinking, including goals, and all of that. I mean, imagine you can tell this thing, to accomplish stuff for you, and it goes and does it. And it pipes up every now and again and says, hey, I found something for you. Okay. See, Alexa doesn't tell you things. You can't tell it to do something that might take it 2 months to do.
Mm.
And it's actively working on it while you're not there. And then every so often it tells you, hey, I'm still working on this. And, oh, I've accomplished this. And then at the end it says, yep, I've done it. It's all done.
I think it's like you're totally right. It's like this is problem with a personal assistant. Like, what is a personal assistant? In the real world, if you have an assistant there, you will tell them, please think of this for a couple of months and give me an answer when you finish, right? And they'll just do stuff. They'll figure it out, and then eventually they'll have their own way of figuring it out, and they come back to you with an answer. I think Alexia will totally right. It can do small tasks which you have to pre-program, but it's not going to do thinking. Like, you can't tell Alexia, can you please think about this and figure something out on your own,
or
right?
just do a large task.
Yeah.
You know,
yeah. That would require
like Savant, do my taxes for me.
Yeah, that would be actually yeah, exactly. I would go Alexia. Alexia will say, "Come again." I don't know what you're talking about.
I'm sorry, I can't handle that one.
Yeah, exactly. Or it'll just not listen to you like Siri does. Yeah, for example, it'll just totally ignore you. Yeah, and I totally get that. So I suppose then maybe we'll continue on this. But fundamentally, I think that's great because we believe that it's going to give a good product for everyone, and it also enable a few cool features, right? Because I know how systems work now. The way we use this personal assistant is basically we have a device, and then we teach it a few tricks, and then we have this concept of adding more tricks to it. Yeah, and the tricks are usually done the same way. You know, I've built this similar system for my son where he presses a key and it speaks to it. That's great, right? But fundamentally it knows the inputs and it transfers them into text and makes them into voice, right? And it basically detects strings. Like if this string is this, then I do stuff, right?
Right.
And that's not really kind of thought, right? And it's not really be able to kind of understand symbols, right? It's symbols at the very lowest level, right? So I suppose once we have a brain, and it's going to be probably a power of it to be able to not just transfer, like right now, if I have Alexia and I can teach it to read the news, I can transfer that skill per se to somebody else via plugin, but it'll be interesting to be able to demonstrate to people transferring knowledge. Yeah, actually go.
Yeah.
I transfer actual learning, because obviously GPT-3 can't transfer its knowledge to anything else because it's not based for it. But
well, when you transfer knowledge, that's when it becomes information.
Mm-hmm.
Right. That's what information is. It's knowledge transferred. Because you can't inform yourself unless you're reading something you've never read before.
Yeah.
Then you're transferring the knowledge from that book into your mind. So that is information that's coming in. Once it's in your head, it's knowledge.
Yeah.
And then once you and then if you want to tell somebody something, you're giving them information because you're informing them about that knowledge. It's up to them to integrate that information into their own mind, and then it becomes knowledge if they do so.
Yep.
A lot of people are confused about those two, and it's good to get those straight.
Yeah. It's almost, we have had a session about it at one point as well. Yeah, and it's obviously, I see still LinkedIn articles talking about it, and it seems to be misunderstanding. But I suppose, there's a nice communication diagrams that demonstrate that the information is a transmittal of essentially knowledge from your part, and some sort of a creation of knowledge on the other part, right? And we know that. I think we've talked about it at length. That if I was to say something to you, you would have to have some sort of prior knowledge to be able to connect to it, because you might just go, "That doesn't make sense to me." Right. Like when we say to GPT-3 about the birthday suit, it got no idea. It knows about the birthday and the suit,
right?
And it's a suit. Yeah, I can wear that, and it's because of your birthday. Happy birthday, by the way. It's like, okay. No, it's not my birthday, and it's not a suit. It's like that's a good demonstration of it.
Right.
That's pretty cool. I think we're getting pretty close to an hour now, and we have quite a few topics. So maybe what we'll do is we will have another session and we'll go more deep dive in this, because I think I'd like to see.
Yeah. There's plenty more to go over, so I was expecting that we would do that.
Yeah, and we will the next session we're going to have with everyone is we will talk about the project program, so that we can actually explain to everyone how the project will pan out and how this will come to life to everyone. I think that's going to be interesting for everyone to hear, and it'll give everyone a bit of an insight into how this will come to life, and it'll enable these capabilities.
Yes.
Yep. Well, I think with that, let's wrap it up. Ken, what do you think?
All right.
Yeah.
Sounds good. That was a good talk, Max.
It was
I hope everybody enjoyed it, and we've got a lot more.
Yeah, let more. And
to-
once again, yeah, if you
Yep.
guys have some questions, ideas for us, please feel free to reach out to us on LinkedIn, on YouTube, post the comments, send us emails.
Yep.
Anything you can do, get across to us, and we'll be happy to help you guys.
And we're very friendly to talk to, so just send us little messages
yeah.
or whatever.
It's
Yep.
number one priority. It's our goal. Yeah,
Yep.
we're not here to mine people's information and then get rid of them like some AI systems. We're here to really enrich everyone and raise everyone's
Yep.
birds.
That's right.
We'll
I
talk
agree.
more about that. Actually, that should be a good topic.
Okay.
Thanks, everyone. See you next
All
time.
right. Bye-bye.